rational function that is equal to some constant, and just I'm going to write down just a brief geometric insight to this thing. The right hand side is constant. That means it's equal to 2 for all values of x. And so what we have here is what they call a horizontal asymptote. And I'll just draw it. It's normally depicted by perforated lines or dashes. So the graph of this function may or may not cross this, but this is another name for this is just the line y equals 2. Y equals a constant corresponds to a horizontal line. X equal to a constant corresponds to a vertical line. Okay, so we want to know how many times this rational function intersects this graph y equals 2. All right. Now, another thing that's very, very useful to note is that notice that 4 plus 40 divided by 2 is equal to 11 plus 33 divided by 2. All right, folks, both of these numbers are what, equal to 22? 44 divided by 2 is 22, and 33 plus 11 is 44 divided by 2 is 22. So this gives us an opportunity to exploit symmetry. Right now we have a graph that's not symmetrical. If you multiply this out, there's no symmetry present at all. However, if we allow for this substitution, u is equal to x plus 22. Notice the 22 right here. 22. Okay. It transforms this expression that possesses no symmetry into an expression that is symmetric about the vertical axis or the y-axis in this case. All right, now notice that just the top one, both of them have u squared terms present, right? So you have u squared minus, what is this, 324 over u squared minus 121. Now just remember all the way back in college algebra, this is a function of u, so we can call it f of u. I got to be careful how I say that. F of u. Okay, and notice that this is equal to f at minus u. And that means this is what they call an even function. An even function is just a function that's symmetric about the vertical axis, or the y-axis, which is it's most normally called, right? So you see the symmetry creates some favorable algebraic consequences here. So I've just expanded everything out here, and in the same breath I multiplied by 2. 2 times minus 121 is minus 242. And if you collect all the terms, take square root right here, you get minus the square root of 82i equals u. So that's a purely imaginary number. But if you take that back to our substitution here, u is equal to x plus 22. Let's just write it down here. U is equal to x plus 20, or I'll say u minus 22 is equal to x. That'll be more favorable. We are trying to solve for x, right? I should put plus or minus here, folks. U is equal to plus or minus. Okay. Now, so what does that do for us? Well, that gives us two solutions. One solution would be x equals to -7 plus the square root of 82i. And also x would be equal to -7 minus the square root of 82i. Right? So we get two solutions, two complex conjugate solutions. And I just want you to note, and again, a lot of you are probably familiar with this, but exploiting the symmetry makes this thing substantially easy. This is easy to solve because there's no linear u terms involved. And so you just get u squared equals a constant. solve for u, and then you appeal to our substitution, and you, let's see what I have, -7 there. That should be -22. Sorry. Yeah. Yeah. I don't know where that came from. Let me erase that. So we have -22 here, folks. Don't know what I was thinking. That may have been some other problem. So -22. There it is, ladies and gentlemen. Those are the two solutions. And I'll just, one last parting comment. The other approach would have been just to multiply this out, but you would have had a 44x linear term on this side, and then you would have had an 88x linear term on the other side, and you'd be stuck with a quadratic with really good, 1320 would be your constant term, or something in that range would be, 40 times 33 is 1320, right? So you would end up with a quadratic expression that would be some work to do that. You could do it, but it would, and again, it would take slightly more. I think this is the best approach. Just let me know in the comments if you agree, that exploiting the symmetry is simplest here. It's worth the time to make this substitution just because it simplifies the calculations in the algebra substantially, in my opinion. All right, thanks for viewing.